Hey guys, welcome again. So we are done with the linear regression, hypothesis testing, and we are now moving to confidence interval. Um, so with the confidence interval, we have two questions, and you are supposed to provide your answer here for the first question, and also for the second one, you have to provide your answer underneath. So let's look at the first question. It says, suppose we have collected data from a sample and the sample mean is 7 and the margin of error is 2.5. So we have the margins of error of plus or minus 2.5. If the confidence level is 95, then we need to find the confidence interval for the true value of the population mean and explain the outcome. So you can see that the sample mean is our point estimate, and we're given the margins of error of 2.5, and also we're given the confidence level, which is 95. So I'm going to show you example that we work together in class to see how did we find the confidence level. So here we have this question. So the question says, suppose scores on exams in statistics are normally distributed with an unknown population mean. So that means we have no idea what is the population mean, and but we know the standard deviation of the population to be 3 points, and a random sample of 36 scores is taken and has a sample mean of 68 points. So we need to find a 90% confidence interval for the mean exam score, and we are supposed to interpret the confidence interval found in the first part, and also we need to answer the question, is it reasonable to conclude that the mean exam score for all the exams is 70, and we need to explain why. So all we need is to find the average of the population, which is not known. However, we can estimate this average by looking at the margins or the limits, the lower limit and the upper limit from the point estimate. So our point estimate is the sample mean that is obtained from the sample data, and our sample, which is n, is 36. So let me organize our information here. So the sample size, which is n, is 36. And so the average of the sample is 68, and the standard deviation of population, or the standard deviation of the big data, is given as 3, so 3 points. Now we are given 90% as our confidence level. So we need to find the intervals for the this unknown population, or the average of the unknown population, to see where it can be, given our point estimate, which is 68 points. So how do we find the limits? So given this information, we can actually find the confidence interval. So the formula for confidence interval is given as the point estimate, which is the average of the sample, and this should be plus or minus the margins of error. And in this case, we are not given margins of error, and so we need to calculate that margins of error. And the good thing is we're given 90% confidence level, and also we are given standard deviation of population. And so in this case, we should use the z value. So we're going to put z times the standard error, which is standard deviation, divided by the square root of n. So we can close the bracket, this one if necessary. And so you can see that our point estimate plus or minus the we call the margins of error. Let me highlight this. And the margins of error will be given by the z value times the standard error, which is standard deviation divided by the square root of the sample size, which is 36. And so we'll find the margins of error of positive or negative. So let's go back to your question. So you can see that in this case, we have the sample mean, which is 7, and the margins of error, which is actually calculated, and that's 2.5. And the confidence level is 95. So I will say you don't have to calculate the margins of error because this one is already provided, but I'm sure for this question you have to calculate the margins of error. And to calculate the margins of error, you have to follow, or you have to use this formula of confidence interval. So the first thing we need to do is to find the z value. And the z value can be obtained if we have a probability. And you can see that the confidence level of 90 will actually give us the z value. So all we have to do is just to put the equal sign, and we type norms inverse. And in this case, we will need to put this probability here. So we can click on the probability, close the bracket, and enter. I have to explain this function. So this is for Windows 2007. So let me show you. You can see that this function is available for compatibility with Excel 2007 and earlier. But we could use the most current, where you can put the dot between S, and so that formula will be the same, norms inverse. And in this case, you will need to just put the probability. And you will click on the 90%. The answer will be the same. Whether you use the formula or the function for 2007 or the most current, that will be fine. And so in this case, just enter. And our z value is 1.28, 1552. That is the z value. And then we need to know the standard deviation, which is 3, and the square root of n. So let me put here SQRT of n. So our n, or the sample size, is 36. So I'll put equal sign and then type SQRT, the square root and I'm going to click on the 36 and close the bracket and enter. So we have the square root of n to be 6, and so I'll take the standard deviation divided by the square root of n. So in this case, I'll put equal sign, click on the standard deviation of population, divide by, that's the standard deviation, divided by the square root of n, which is already found, and that is 6. So you can enter, and we have 0.5. So we'll take the z value times the standard deviation divided by the square root of n, which is 0.5, to get the yellow shaded area, or this section here. So I'll put equal, and then I'm going to click on the z value, this z here, times the what we have here, that is 0.5, and that's the standard deviation divided by the square root of n, and enter. So we have the z, not the z value, so the margins of error will be 0.640776. So we can bring this to 2 decimal points. So we have the margins of error of 0.64, and which is different from what you have. The margin of error here is 2.5. That's your point estimate, and for me my point estimate is 68. So we'll take the point estimate plus or minus the margins of error to get the lower bound and the upper bound. So I'm going to write here the lower bound, or we call lower limit, and we can find also the upper limit. To get the lower limit, we will take the point estimate, which is the average of the sample, minus the margin of error. So I'll put equal sign, click on 68 minus the margins of error, and so I'll get the lower bound, which is 67.36, and for the upper bound I will click on 68, and now I'll put plus the margin or the margins of error and enter. So I will have 67 and 67.36 and 68.64. Those are the margins of error. And I think I'm done with this. The question is C. So find a 96 confidence interval for the mean delivery time. So the unknown population mean. And so in this case, I'll write the report here to say we are, so let's say we are going to use the confidence level. So we are 90% confident that the unknown mean of population lies between the lower limit, which is 67.36, and the upper bound, which is 68.64. So let me highlight this. So this is how we can interpret these results. As I said, the average of a sample, which is obtained from the normally distributed data with unknown population. So that we can use as our point estimate, where we can estimate the average of the population. And we know that with this point estimate, the average of the population should be between 67.36 and 68.64. So the lower and the upper boundary will provide the area where the average of the population can be. And so, coming back to your exam, So as I said, the margin of error is 2.5, or you can say the margins of error of plus and minus will be is 2.5. And in this case, for me, I calculated and I got 0.64, and with confidence level of 95. And so finding the confidence interval for the true value of the population. So so in this case, you should take 7 minus the margins of error, minus to get the lower bound, and you can add to get the upper bound, and then your interpretation should be or can be like what I just provided. That's what you have to explain. And for the second question, which says, suppose average pizza delivery times are normally distributed with the unknown population mean, and population standard deviation is provided, which is 6. A random sample of 28, so the sample size is 28, and this is taken and it has a sample mean delivery time of 36 minutes. For me, I have 68, and it is standard deviation 68. So we have standard deviation. Yes, that standard deviation is provided. So the question says, find a 96% confidence interval for the mean delivery time and interpret the confidence interval found in part 1. Now the question is it reasonable to claim that the mean delivery time is 35 minutes? And explain. So actually, I'm supposed to explain the same part here, which says, is it reasonable to conclude that the mean exam score for all the exams is 70? And explain. So you can see that the upper limit for me is 68.64. However, we have 70. That's way beyond the upper limit. And so it is not reasonable to conclude that the mean exam score for all the exam is 70. It is outside the margins of error. So we are allowed the average to fluctuate between 67.36 and 68.64, and therefore this one is outside the margins of error and we cannot accept it. So if you work on this question, let me see if 35 will be within the margins of error or it will be outside the limits.